Good morning, class. In our last class, we have started the revision for our chapters, and the first chapter we have studied was matter. Today we'll continue to do so. So, as we know, the empty spaces between the different molecules of a substance are called intermolecular spaces. We have seen this in the last class. So, whatever space is present between the different molecules, we call it as intermolecular spaces, and we have also seen how the order of intermolecular spaces will be in case of solid, liquid and gas. Similarly, the force of attraction between the molecules of a substance is called intermolecular force of attraction. So the force of attraction that exists between the molecules of a substance we call intermolecular force of attraction, and we have also seen the order in case of solid, liquid and gas. A change in the state of matter depends on three things. That means the change of a state, that is from solid to liquid or from liquid to gas or vice versa, will depends on three things. The first is intermolecular space, the second one is intermolecular force of attraction, and the third one is the collision between the molecules. So these three factors are responsible for the change in the state of matter. Next, the intermolecular force is the strongest in solid, as we know, because in the solids the molecules are very close to each other. In liquid it is not as strong that in solid because it is far away from the molecules, and it is the weakest in gas. And in case of gases, since the molecules are very far away from each other, they have got weakest intermolecular force. Now, a very important law of conservation of mass. The law of conservation of mass states that matter is neither created nor destroyed during a chemical reaction. So, according to the law of conservation of mass, it says that matter is neither created nor destroyed during any chemical reaction. That means there is no change in mass during a chemical reaction. So, when you carry out a chemical reaction, there is no change in the mass. Say, for example, magnesium plus oxygen gives you magnesium oxide. Now, when you take the weight of this magnesium and oxygen before the reaction, and if you take the weight of the magnesium oxide after the reaction, you'll find that both the masses of the reactant and products remains the same. This means that law of conservation of mass holds there. Okay, now today's assignment number 8. Question number 1. Name the attractive forces between the molecules of a substance. Question number 2. When a solid is heated, what happens to its molecule? Question number 3. Explain the law of conservation of mass with an example. And question number 4. As magnesium bonds in oxygen to produce magnesium oxide, there is no change in mass. Explain it. So complete this assignment and send it in my mail.